All right, we're going to get started here. Thank you guys for showing up. Thanks for vBrownBag for setting this up today. So first talk today, AWS 101. I just thought it was kind of weird. We're talking about something that's, I guess up until the recent announcements, it wasn't really related to this conference at all, but there's been a lot of interest in AWS, obviously, so thought it'd be good to go through a 101 here real quick. So there's a normal disclaimer about me, do things, lead two groups, took some tests, etc. So really, we'll kind of get into it here. Where do you start? A lot of people are confused, with a lot of the services. There's 60 services, and it feels like they're constantly announcing additional services at every conference and every little meetup that they do. So it is a little intimidating, at first, because there's so many options. But you always tell people that you don't have to be an expert at everything. A lot of folks will focus on certain areas, and I think you'll find that a lot too in like consulting services, right? They focus on the storage or migration or something like that as well. So I always tell people to start with the basics, right? And these are kind of topics we'll quickly cover today. We only have like 12 to 15 minutes, so I'll talk fast. But access and identity management, so users, how do you log in, networking, compute, storage. Those are kind of things that most folks start with, and then you kind of expand from there beyond the basics. So we'll talk about those. So one of the key concepts in AWS Regions versus availability zones. So really, how many data centers is your workload going to run in? Each one of those yellow ones, this may be a couple months outdated, but each one of the yellow circles represents a region, and the number inside is actually an availability zone. The green ones are regions that have been announced. And I think the only change I noticed on there, Northern Virginia says 5, it should be 6 now. They just added additional AZ. So what it looks like, you got your region, the bigger box, that would be Northern Virginia, that would be Oregon, that would be Northern California. Then you have AZs within that region. So you think of those as distinct data centers that are completely separate from one another. And they do have low latency, high bandwidth connectivity between all the AZs within a region. It's also important to know that outside of like the native features that you get with a lot of the AWS services, there's no connection between the two. So if you're running workloads and want to migrate, if you're running SQL or something like that on an EC2 instance, you want to copy that, there's no really direct link between the two. You have to kind of create that. So example, US, west there, east, etc. IAM, that's how you authenticate and access AWS. So it manages your users. So that's for console or API access. Groups, same thing as like a Windows environment. You put users in a group, you assign permissions to the group. Roles is something a little different for AWS. Ultimately, you want to move from using users and groups into roles using like something like ADFS, where you're federating Active Directory into the console using your normal credentials. And then those users or roles, they get assigned access policies, and those basically define the permissions that you are allowed to things you're allowed to do on AWS. So you're a developer, you want to restrict read-only access to your VMs, you can do that as well, or you can allow your administrators, full-blown access. So what does it look like federation-wise? So you have an Active Directory group. It generally matches up with a role that you have within EC2, and then you can assume a role into either that account for stronger permissions or into a different account. Say if you have a production account, development account, test account, etc. So VPC. So kind of choose your own adventure, right? It's your own dedicated kind of space. It's really, VPC is really everything networking within AWS. So bring your own IP addresses, create subnets as you need. You select the routing and how traffic gets routed, whether it goes out the internet straight from AWS, or if it goes back to on-prem if you already have stuff set up there. Connecting things to it, right? So internet access, like I said, whether that's outbound to the internet or inbound traffic to a workload running on AWS. How do you manage connection back to your on-premises data center for, say, if you have web servers out in the cloud and you want to connect them back to the databases running on-prem. And then cross-cloud connectivity. So really, what I always tell people is kind of the building block for AWS. It's kind of the foundation for your cloud. So you want to make sure that you always plan for the future, right? So plan now, build for later until you give it to a developer and he smashes it all down. So Some of the pieces of the VPC, subnets, I'm not going to go through the whole thing, but they're all basically, like you said, networking concepts. Compute, EC2, so really those are your VMs on AWS. They call them instances, they're not VMs. On AWS, the templates, what you refer to deploy from a template, they're called AMIs or AMIs up there. So you can create custom AMIs, you can use the native AMIs already, or you can actually upload your own. Wide array of instance sizes, right? So the smallest is T2 Nano. I think Nano may be smaller than Micro, but 1 vCPU and only 512 a meg, so have fun running Windows on that one. Or you can get up to like an X1 32 extra large, 128 vCPUs and like 2 terabytes of RAM. And then they also have a lot of the instance types are workload optimized, right? So you get compute optimized, memory storage, graphics optimized, T&M, generally purpose workloads. So we typically tell people to start with T&M, and then if you need additional compute, memory or storage capacity, you can migrate to those. Pricing model, on demand, that's what you're probably most familiar with. No upfront costs, right? Pay for what you use. You spin up the EC2 instance, you start paying for it, you shut it down, you stop paying for it. You can do reserved instances, so if you have things that are going to run long-term in AWS, you can do a 1-3 year commitment. You can save up to 75% on those instances if you do reserved instances over the on-demand pricing. Spot, those are really bidding on unused capacity in the AWS platform. Very limited use cases on those. Really, if you have a spot instance, they can rip it from underneath of you. They give you a 2-minute warning and then it's gone. So, and then you can have dedicated hosts as well. Obviously, those are more expensive. And then you have multiple options for storage. EBS is kind of like your drives that you deploy to VMs now. You'd say your CED drive that you would do on your VMDKs. You have instance stores. I should say EBS. Those can be used for long-term storage. Those last even if you shut the VM down, assuming you change the default setting to destroy it. Instance store is really ephemeral. So think of a non-persistent disk in VMware. So if you shut it down, that data's gone. However, it's very fast storage, so there are use cases to take advantage of that. And then you can also include other storage options, EFS, S3, Glacier, et cetera, that we'll talk about. EC2, you also have ELBs, elastic load balancers, so those are really your soft load balancers. So they have the ELB, which has been around for a long time, mostly layer 2. Then the application load balancer, those are layer 7. Those are a little newer, probably about a year now, I guess. Auto-scaling groups is what I always say, like the real magic in AWS. So it allows you to scale up and scale down based upon user load. You can also use those just to make sure, kind of like an HA, right? You can say, I want one instance, always one instance, and if it dies, it'll automatically create that instance for you. Provides resiliency, high availability, just like any other load balancer would do, and you can scale for performance, right? So if you have increased workload, you can automatically scale up VMs behind the load balancer, handle that workload, and then shut it down after traffic decreases. Elastic, so this is EBS, so this is around the storage on EC2. So elastic block storage is really the default for most instances. Like I said, similar to VMDKs. You can do SSDs, which is the default now, or you can pick a hard drive, which is a magnetic drive. GB2 is the default. You get 3 IOPS per gig when you deploy it. So if you deploy a 100 gig drive, you get 300 IOPS by default. If you need more than that, you can do similar to SILC, where you can say, I need a 100 gig drive and I need 3,000 IOPS, and you can deploy that as well. Magnetic storage, obviously slower. They renamed it, whatever. Backups based on snapshots that are actually stored on S3. Storage here, outside of compute now, object storage, S3, probably the most popular one on AWS. Super cheap, data stored in buckets. You create buckets, you create bucket policies to apply who can get access to that data, whether it's publicly available or not. It's got 11 nines of durability, it's not a typo, and then it has 4 nines of availability. There are also native features where you can select a checkbox and you can migrate to a different region if you need that data redundancy. 3 tiers. IA is really not, you have to kind of search for it now, but the biggest tier, S3 is the normal tier, and then they have RS, which is reduced redundancy storage. So instead of storing that in 3 AZs, it stores it in 2. It's cheaper. Glacier, you probably heard of as well. It's designed for long-term storage, cold data, etc. It's cheaper than S3. You can store it in archives. Up until probably 6 months ago, there's only the standard retrieval time, 3 to 5 hours. So if you ever take an AWS test and they say that you need the data back in less than that, always choose S3 over Glacier. But it costs more to do expedited. You can get it 1 to 5 minutes, and you can get things in bulk too. So restore costs used to be a lot more expensive than they are now. They slashed a lot of the prices. You kind of see the price there, and there's some, you can see what it's compared to versus S3. 25 terabyte for reduced redundancy storage, $604 versus only $102 in Glacier per month. So moving beyond the basics, right? So RDS, that is basically hosted databases on AWS. So instead of having to spin up an EC2 instance and running SQL or MongoDB or something like that on an EC2 instance where you're still responsible for both the underlying operating system and the database and the data within it, now you let AWS handle everything from a operating system side and the platform, and then you just manage the data. Route 53, you guys probably familiar with that, DNS. So you can use that both internal and external. Most people use external. I know a lot of people that run Windows workloads will use a DC like normal. Cool features, it does integrate natively with a lot of AWS services. So as you're picking, say for example, you put an A record in there to point to your web server, and you can put a secondary. You can point those both to an ELB in both of those availability zones, and those ELBs will tell Route 53 which data center to point to based upon the health of the instances behind those ELBs. Storage gateway, almost took that one out, found something different, but it's kind of cool. You can actually install that on-prem, and you can point that to an S3 bucket. So anything that you put data on-prem, it'll copy it out to S3, or vice versa. It can be a cached, like kind of a cached server, and everything's natively stored on S3. CloudFormation, as you get more serious on AWS, this is really where you want to be. Right? So automate all the things, like everything. So you can build up whole environments there, tear them down when you're done. So for example, a development environment where they're trying to stand up an application, test it, they only need it for a couple hours. Automate that with CloudFormation or Terraform. And then as you spin it up, does everything for you. Spin it down, it takes care of everything, including firewall rules, DNS, everything. So gets rid of all that technical debt for you. Learn more. So vBrownBag, obviously, I think there's been two or three series around the tests. So I presented on 2 of those. AWS has a free tier. So you sign up for a new account, you get 12 months free. Quick Labs. You can do those kind of like the hands-on labs. A-Cloud Guru is a good one. Obviously, reInvent. It's coming up at the end of November. Study for the AWS certifications. They're not terrible, promise. I blog some stuff on there as well. And that's about it. Thank you.